Good afternoon, my YouTube viewers. It is Crystal here. I'm just here to give you a code review. And this code review is going to be about JAX, multinomial logistic regression. And we're going to be using the iris dataset. And we're going to be using the softmax algorithm on it. This is going to be with JAX, which is a very powerful library. It's similar to NumPy, so if you know how to use NumPy, then it won't be that difficult to use JAX. JAX is supposed to be overtaking TensorFlow for research purposes at least, so it's important to learn JAX if you want to be a machine learning specialist. So I wrote this program on Google Colab, which is a free online Jupyter notebook hosted by Google. It's a great platform to use to write code, but the only thing about it is it doesn't have a very good undo function. So you need to be careful not to accidentally overwrite or delete any valuable code. But if you do that, you can go into the change history, and in the change history there is a possibility that you can retrieve code, but it's not guaranteed, so you need to be very careful not to do it. So the first thing we do after we created our Jupyter notebook is we want to import our libraries. So we're going to import JAX. We're going to import jax.numpy as JNP. We're going to import from JAX. We're going to import grad, JIT, and VMAP. From JAX, we're going to import rectum. From sklearn, we're going to import datasets because we're going to be using the sklearn dataset. From sklearn.model-selection, we're going to import train test split, and we're also going to import Seaborn as SNS to view the data. So after we have imported the libraries that we're going to need, what we're going to do is we're going to load the dataset. So iris equals dataset.load iris, x equals iris.data, y equals iris.target, and we look at x so you can see what x looks like. And then now what we're going to do is we're going to visualize the targets using Seaborn Displot. And when we visualize the targets, you see that there are three categories of 0, 1, and 2. And these three categories, it's a balanced data set, so that's good. And it's a multinomial logistic regression. So now what we're going to do is we're going to standardize the data. X equals x minus x mean over jnp.stdx. So we're going to standardize the data. So the data is going to be the standard deviation of the data. And then after we standardize the data, we're going to use sklearn train test split to split the data into training and testing sets. So x train, x test, y train, y test equals train test split, x, y, test size equals 0.3, random state equals 42, print x train, x test, y train, y test. And so you can see that on the x, on the features, you've got 4 columns each, and the target, you've got 1 column. So now what we're going to do is we're going to create the multinomial logistic expression. So the first thing that we're going to do is we're going to add bias term to the features. So what you're going to do is you're going to add a column of 1s to x train. So, and then after you add a column of 1s, then what we're going to do is we're going to one-hot encode the target. So num classes equals len jnp.unique y train encoded equals jax.nn.one-hot y train num classes, and then we printed y train encoded, and so it's just one hot encoded data. we're going to define the softmax function. So your softmax function is your multinomial linear logistic regression function. So def softmax x, expx equals jnp.exp, that's an exponent, over x minus jnp.max, x-axis equals 1, keep dims equals true. So axis equals 1. I think it's going to be columns, but I'm not sure. Let's look and see. We'll say numpy because they're very similar. Axis 1 in numpy is the second axis. But I think axis 0 is rows and axis 1 is columns. Rows are considered to be axis 0 and columns along axis 1. So we're just going to say it's axis 1 and it's columns. Return exp over x, jnp.sum, exp x, axis equals 1, keep dims equals true. So that's what it returns. Now we're going to initialize the weights. And when we initialize the weights, you set num features equals xtrain.shape1, key equals random.prng key 42. So that's your random number. Weights equals random.normal, key num features num classes. So that's your weight. So it's going to generate a random numbers based upon the key and the number of features, that's your number of columns, and your number of classes, that's your number of classes. And then you print weights, and we've got that printed out. Now what we're going to do is we're going to set up the hyperparameters. So learning rate equals 0.1, num epochs equals 1000. So an epoch is when the for loop iterates through each row of the data set one time. So every time the for loop iterates through the data set once, that's an epoch. So now we're going to set up the training loop for epoch in range num epoch, so that's 1000. Logits equals jnp dot xtrain weights, so that's the dot product of xtrain and weights. Probs equals softmax logits, so that's your probability. Probs is going to be your probability when you put logits into the softmax function. And then you compute the gradient of the loss. Cross entropy, grade loss equals jnp dot xtrain t, that's xtrain transformed. Probs, that's your probability, minus xtrain encoded over the length of xtrain. And then update the weights using the gradient descent. So weights equals weights minus learning rate times grade loss. And then so you can see here's the one hot encoded, and then here are your weights. So you can see that. And after we've done that, after we've trained the data, we've set the hyperparameters and set the weight and trained the data, then what you want to do is you want to make predictions. So test logics equals jnp dot x test weights. So that's the dot product of x test and the weights. Test probs equals softmax test logics. So you're going to put test logics through the softmax formula, and predicted labels equals jnp dot argmax test probs axis equals 1. So that's going to be the max. It's going to give you basically this matrix right here, this is your predicted labels. And then what you're going to do is you're going to select, well, this is your, test probs. And then you're going to select the maximum value. And the maximum value is going to be your predicted labels. So here we'll start out at the very end one, and it's 0. So you got 9, 3, and 4. So that's 0. It selects 0. The next one is 0. So you got 9, 2, and 2. So 9 is your highest. It's going to be 0. The next one is going to be 1. It's going to be 3, 5, and 4. So 5 is your highest. So it's going to be a 1. The next one is 1. It's going to be 1, 6, and 3. The 1 is the highest. So it's going to be 1. And the next one is 2, 1, 3, and 6. So 6 is your highest, so it's going to be 2. And so I had to do that backwards because it's so big, but you can see that what the argmax does is the argmax selects the highest value. And so I just tried to show you the highest value on the printout. And then now we're going to calculate the accuracy. And so the accuracy metric for X test and predicted labels is 100%. So that's good. It got 100% right. We're going to compare this to sklearn's logistic regression. So model equals logistic regression, class weight equals balanced, random state equals 42, max ITER equals 1000, solver equals LBFGS, multi-class equals multinomial, fit X train Y train, and you had 95%. But then we check ypred equals model.predict X test. Then you got ypred, and you can see you got all that as well. So check our accuracy, and your accuracy is 100% as well. So the JAX softmax algorithm and the sklearn algorithm work exactly the same. But the way they do it in sklearn is they call it logistic regression, and then you set it up for multinomial. But it's done a little bit different in JAX, because in JAX, if it's a binary classification, you're going to use logistic regression. But if it's a multinomial classification, you're going to use softmax. So the logistic regression and the softmax are done differently. So that's it for this code review. So I'm going to go ahead and conclude this video because we've covered everything in the code review that we want to cover in the code review. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more code reviews for you in the future.